Have you ever discovered something you have been searching for years? The joy of discovery is not new to NASA, but with the latest discoveries, that team is much closer to knowing just how much life is in space. In the spring of 2021, when NASA's Perseverance Mars rover started studying rocks on the floor of Jezero crater, the scientists discovered something unexpected. They had anticipated discovering sedimentary rock, which would have formed as sand and mud settled in a formerly watery environment because the crater had once hosted a lake billions of years ago. Instead, they found that the floor was composed of two types of igneous rock, one created by volcanic activity on the surface and the other by formation of magma deep down. The discoveries are detailed in 4 fresh articles released on Thursday, August 25th. A second study in the same journal, Science, describes distinctive rocks that appear to have formed from a thick body of magma. One study in the journal provides an overview of Perseverance's exploration of the crater floor before it reached Jezero's ancient river delta in April 2022. The other 2 papers describe how Perseverance's rock vaporizing laser and ground-penetrating radar established that igneous rocks cover the crater floor. Both papers were published in Science Advances. Crystals found in the igneous rocks serve as effective timekeepers by preserving information about the precise moment of formation. The igneous rocks we found have a lot of importance because they can tell us when the lake was present in Jezero. According to Ken Farley of Caltech, the project scientist for Perseverance and the primary author of the first 2 of the science studies, we know it was there more recently than the igneous crater floor rocks produced. This will answer some important queries. When did Mars's climate change to the extremely chilly and dry conditions we see today? And when was it conducive to lakes and rivers on the planet's surface? Igneous rock isn't the best material to preserve the possible traces of prehistoric microscopic life, though, due to the way it forms. In contrast, dating sedimentary rock can be difficult, especially if it includes rock fragments that developed at several points before the deposition of the rock sediment. However, sedimentary rock frequently originates in wet conditions favorable for life and is better at preserving prehistoric life traces. That is why scientists have been so intrigued by the sediment-rich river delta that Perseverance has been exploring since April 2022. To potentially send sedimentary rock core samples to Earth for analysis by powerful lab equipment that is too huge to travel to Mars, the rover has started drilling and gathering core samples there. An old Mars enigma is resolved in a second publication that was published in Science. Mars orbiters once discovered a rock formation rich in the mineral olivine. This structure spreads from the inside edge of Jezero crater into the vicinity, covering an area of around 27,000 square miles, or almost the size of South Carolina. Numerous explanations, including meteorite strikes, volcanic eruptions, and sedimentary processes, have been put up by scientists as to why olivine is so abundant over such a broad surface area. According to another theory, the olivine may have formed deep underground from molten rock that was slowly cooling. Over time, erosion may have exposed the olivine. The last theory is the most plausible, according to Yang Liu and her co-authors from NASA's Jet Propulsion Laboratory in Southern California. The scientists focused on the huge grain size of the olivine as well as the rock's chemistry and texture after persistently abrading the rock to reveal its composition. They discovered that the olivine grains in the area measure 1 to 3 millimeters using Perseverance's planetary instrument for X-ray lithochemistry, or PIXL, which is significantly larger than predicted for olivine that formed in fast-cooling lava near the planet's surface. According to Liu, the big crystal size and homogeneous composition in the particular rock texture necessitate a prolonged cooling environment. Therefore, it is most likely that Jezero's magma wasn't exploding on the surface. The 2 Science Advances papers describe the results of scientific tools that contributed to the discovery that the crater floor is covered in igneous materials. The equipment consists of the SuperCam laser from Perseverance and the RIM-FAX ground-penetrating radar. A target as small as a pencil tip can be zapped by SuperCam's rock vaporizing laser from a distance of up to 20 feet. It uses a visible light spectrometer to analyze the resultant vapor and determine the rock's chemical makeup. During Perseverance's first 10 months on Mars, SuperCam zapped 1,450 sites, aiding researchers in concluding the presence of igneous rocks on the crater floor. SuperCam used near-infrared light to discover that water altered minerals in the crater floor rocks. It is the first instrument on Mars with that capability. However, the combination of laser and infrared studies showed that the changes were not widespread across the crater bottom. Roger Wines, SuperCam's main investigator at Purdue University, and Los Alamos National Laboratory, stated that the data from the instrument suggests that either these rock layers were isolated from the lake water of Jezero or that the lake exists for a brief period of time. Another first is RIMFAX's use of ground-penetrating radars, which Perseverance is the first spacecraft to use on the surface of Mars. Mars orbiters already use these technologies due to its surface location. RIMFAX can give unmatched detail and has surveyed the crater floor up to 50 feet deep. Rock layers are unexpectedly tilted up to 15 degrees beneath, according to the high-resolution radargrams it produces. Jezero crater's development may be dated by analyzing the arrangement of these rock layers, according to geologists. According to Sven Erik Hamren, the chief investigator for RIMFAX at the University of Oslo in Norway, being the first such instrument to operate on the surface of Mars, RIMFAX has proved the potential utility of a ground-penetrating radar as a tool for subsurface exploration. Astrobiology, mainly the hunt for evidence of prehistoric microbial life, is a major goal of the Perseverance mission to Mars. The rover will describe the planet's geology and previous climate, open up the red planet to human exploration, and be the first mission to gather and store Martian rock and regolith. Later NASA missions, in collaboration with the ESA, would send spacecraft to Mars to collect these sealed samples from the surface and bring them back to Earth for in-depth investigation. The Perseverance rover was created and is operated by JPL, which Caltech in Pasadena, California administers for NASA. Spirit and Opportunity rovers from the organization demonstrated that liquid water was once present on the surface. On the strength of that finding, NASA's Curiosity rover concluded conditions on Mars 4 billion years ago may have been favorable for the emergence of life as we know it. Perseverance will now look specifically for traces of a previous existence. On July 30th, 2020, Perseverance began operations despite the global COVID-19 epidemic as an additional hurdle. It touched down in Jezero Crater, the location of an old lake and river delta, on February 18, 2021. In such rocks, which were produced during Mars's warm, wet past, the rover will look for microbial fossils. Additionally, it will search for organic compounds, which are the fundamental units of life on Earth and contain carbon. Perseverance is gathering soil and rock samples as it moves along and storing them in tubes for collection by the next NASA and European Space Agency missions. Many sorts of laboratory studies still can't be performed in space, or it can't be done very precisely, despite technological advancements in producing compact, low-power science instruments for space missions. Furthermore, since science is all about reproducibility, returning Perseverance's samples to Earth would allow us to do the same tests in other labs. The mission is projected to cost $2.7 billion. A compact car-sized, 1-ton Mars rover, Perseverance operates on 6 wheels. Perseverance, which has a similar design to the nuclear-powered Curiosity, can continue to function even when solar-powered spacecraft can't get the sunlight they need due to dust storms. Lovingly known as Percy, the rover made improvements to the challenging 7-minute landing phase, known as the 7 minutes of horror, to land. Perseverance was brought to the ground using a supersonic parachute, a thruster-powered fall, and nylon lines to lower her the final few meters. Perseverance is guided to prospective science locations by scientists and mission operators, using photos from navigation cameras placed strategically around the rover and imagery from orbital satellites like NASA's Mars Reconnaissance Orbiter. Perseverance gathers a sample, places it in a tiny tube, then leaves the tube on the surface for return to Earth if a location is particularly intriguing. It looks like the Mars mission still has a lot more to discover.